Okay, so some more buffer calculations. Don't forget, whenever you're doing a buffer requires that you have a mixture of HA, a weak acid, and A minus, its conjugate base. So there are two ways of making a buffer. There's this one on the left. You simply mix the weak acid with its sodium salt, and that leads to the calculation is a bit easier there when you're working out the pH. Alternatively, a buffer can be made by mixing a weak acid with sodium hydroxide, and then the weak acid reacts with the hydroxide ions to form the conjugate base, and those calculations are a bit more difficult. Okay, so but for both calculations, don't forget we need to rearrange our Ka expression, so it's like that. So we make H plus the subject of it, and we can see the pH or the hydrogen ion concentration is dependent on two things. It's dependent on the Ka, and it's also dependent on this ratio of HA to A minus, the acid to its weak, to its conjugate base. And this ratio is always about 1. When I say about 1, it ranges from between 0.1 up to about 10. And the reason for that is you need large amounts of HA and A minus. So if there's a big imbalance in between them, the ratio was 1,000, you obviously wouldn't have enough A minus for it to be a buffer. So when you're doing the calculation, bear in mind that ratio is always going to be about 1. Right, so let's have a look at a calculation then. Right, this one here, let's do this one, number 1. Right. Make it bigger. Right, okay, find the pH of a solution made, and it doesn't say it's a buffer solution, which is quite often the case. You've got to realize it's a buffer solution, mixing ethanoic acid with some sodium hydroxide. So what kind of a calculation is it? Is the hard type, it's not the easy type. Just to write this equation down, bear in mind what we've got to do, we've got to fill the numbers in here. So H plus concentration is equal to Ka over the concentration of HA times the concentration of A times divided by the concentration of A minus. Okay, and when it's a hard one, we also have to do this. So we say we're having HA is going to react with some sodium hydroxide, the OH minus ion. This is a strong base, it's going to remove the proton from there, so you're going to form A minus and H2O. Right, and then what we do here is we write down start moles, final moles, and final concentration. So we've used this approach really when we were doing equilibrium constant Kc and Kp, and that's quite a good way of doing it. Right, so let's say moles HA. Right, moles HA is, what do they give us? They give us the volume and they give us the concentration. So it's concentration times volume. The concentration is 1.5. The volume is 500 centimeters cubed, 0.5. So that is going to give us 0.75 moles. Okay, so we put that number in there. How are we going to work out the moles of OH minus now? So, right, make some space. Right, moles of OH minus, they tell us, they give us 11 grams. So they're giving us a mass, it's not a solution, so it's not conc times volume, mass, and they give us, it's NaOH. So we need to know, we can use moles equals mass over MR. So the moles NaOH is equal to the mass over the MR, which is equal to, what, 11 grams of it. The MR of sodium hydroxide is 40. So that's equal to 0.275, I think. So let's put that down, 0.275. And we have 0 A minus to start off with, and we've got no water. Well, the water, so we don't care about, we have got water. Right, final moles then. So 1 mole of HA reacts with 1 mole of OH minus, so we subtract. So that's going to be 0.75 minus 0.275, which is equal to 0.475. All the OH minus goes. There'll be a tiny bit left. All this, because you all got a tiny bit of OH minus, and KW. Yeah, but we can. That's insignificant. Ignore that. A minus, we have got, well, 1 mole of OH minus gives us 1 mole of A minus, so we've got 0.275 of A minus. The final concentrations, then all we've got to do is divide by the volume V. Now, this is quite interesting because we don't know the volume V in this case, because yeah, we started off, we know the volume of the ethanoic acid, 500, but then we added 11 grams of sodium hydroxide, so that will increase the volume a bit. We don't know how much it increases it by, but it doesn't matter because we're just going to call it V and it will cancel out as usual. 0.275 divided by V. Okay, so where are we going to go with all that then? Okay, now here's our equation. Now they tell us what the pH is. Oh no, they don't here. Sorry, they don't. Beg pardon. So just put the numbers into the equation. So H plus then is equal to K of ethanoic acid is that 1.7 times 10 to the minus 5 multiplied by my HA is 0.475 over V divided by 0.275 over V. Our V's are going to cancel out. I'm going to work out that fraction because just to show you that it is about, should be about 1, as we've said before. So H plus 1.74 times 10 to the minus 5. Do that. Oops. So 0.475. That is equal to 1.72 recurring. Okay. So we can see that is about 1, which is all good. Okay. And that gives us 3.00 times 10 to the minus 5 as a concentration of the H plus ions. So minus log that to give us the pH. The pH is equal to 4.52 to 2 decimal places. There is our answer. So that was a hard buffer calculation. Okay. Right. Now let's have a look at another one. This one is tricky as well. Okay. What mass of NaOH should be added to ethanoic acid? So look, we're adding NaOH to ethanoic acid, so we've decided it is a hard buffer calculation. Okay, and to make a buffer of solution of pH 4.90. That's been a bit chopped off there, sorry about that. That says buffer. Right, so write our equation down, and we've got to put the number, and we know it's hard, but write down the equation. H plus is equal to Ka HA over A minus. Okay, so hard buffer, we always start off, don't we? We write down HA is going to react with some OH minus to give us A minus and water. And we'll have start moles here. We'll have final moles. And we'll have final conc. Right, start moles of HA. Well, we have 400 centimeters cubed of 0.9. So moles HA. We're going to do conc times volume. Concentration 0.9. The volume 0.4 dm cubed, 400 centimeters cubed. That's 0.36 moles. So we've got 0.36 moles of that. Now the OH minus, this is going to be tricky because we've got to find out what the OH, how many moles of OH minus. So we're going to have to call that X or something like that. We'll call it X. A minus, we haven't got any of that to start off with, and we don't care about the water. Right, so after the reaction, 1 mole of OH minus reacts with 1 of HA, so the final moles is going to be 0.36 minus X. We're going to have no OH minus left. A minus, well, 1 mole of OH gives us 1 mole of A, so that's going to be X for that. Okay, we do the final concentration, so that's 0.36 minus X over V and X over V. Okay, so now we're going to think about what we're going to do, because this is not a run-of-the-mill sort of one. Right, we know HA, sorry, we know H plus concentration because they tell us the pH here. So that's going to be, you know, H plus conc is equal to 10 to the power of minus pH. Yeah, so that's going to be 10 to the power of minus 4.9. We know Ka as well. We know that. So the only thing we don't know is this ratio. Okay, so we can make the ratio subject to the equation. Then afterwards we can find out what the ratio is because we know these, and then we're going to do a bit of algebra and solve for x. That's what we're going to do. So first of all, let's rearrange that. HA over A minus, the ratio is equal to H plus over Ka, which is equal to 10 to the power of minus 4.9 over Ka, which is 1.74 times 10 to the minus 5. So I'm going to do that in my calculator to get what that ratio is. That's 0.723 to 3 decimal places. Okay, 0.724, sorry, yeah, okay. I've left that number in my calculator. That's the ratio, okay. Right, so now we know what the ratio is here. We're going to substitute these values, yeah, these values into that ratio. So we're going to get 0.3, HA is 0.36 minus X all over V, and A minus is X over V, and that's equal to 0.724. So the first thing to do is cancel out the V's. And then the next thing, I'm going to multiply both sides of the equation by X. So I'm going to get 0.36 minus X is equal to 0.724X. Then add X to both sides of the equation. I get 0.36 is equal to 1.724X. And then divide both sides by 1.724. And that is equal to 0.02829. 209 moles. Now that's the moles of OH minus. So the moles of OH minus here. The moles of OH minus is equal to 0.209. So the moles of NaOH is the same, 0.209. So the mass of NaOH is what we've got to find out, is moles times MR, which is equal to 0.209. 40 is the MR of NaOH. Goes up by 40, and we get 8.35 grams. 8.35 grams of NaOH. That is our final answer. So that was a little bit of a tricky one there, okay?